This is the pencil and paper part of project 2. We got a circuit consisting of a CWMF. I'm going to give it having a voltage V in series with a resistor in series with a parallel combination of resistors R1, R2, and R3. And project 2, math function takes 3 arguments, just V, R1, and R2, in that order, creates and displays a graph of the voltage across R2. So I think I'll call this plus or minus V2 as a function of the value of R3. So R3 is to be considered a variable resistor for values of R3 from 0 to 10 times whatever R2 is. Returns nothing. And let's do then. Alright, so that's supposed to be an arrow through R3, which means that it's a variable resistor. And I'm going to use the method of ever simpler circuits. I'll go call this picture 1, picture 2, it involves R1 and R2 and R3 being combined into a single parallel resistor R23, I'll call it, where R23 is equal to 1 over R2 plus 1 over R3. Alright, then picture 3 consists of CWMF and 1 resistor R. I call it RT for R total, which is R1 plus R23. I can calculate the current here. So from I think I'll just say, yeah, that's good enough. In picture 3, or looking at picture 3, I'll call it from 3. I think that's okay. We have script E is equal to I times RT, because the potential difference across the terminals of between the terminals of RT is the voltage across the CWMF. So this VT is just equal to script E, so it's probably even better not to write anything for it. It's just script E. This the high side, because it's in contact with the high side of the CWMF, and this the low side, because it's in contact with the low side of the CWMF. So I is equal to script E over RT. And let's take that up to the next picture from 2. I got V23. So this is the I from the previous picture, and I'll define this to be V23, the voltage across R23 is equal to I times R23. So V23 is equal to I, which we said was script E over RT, times R23. I want to try to get this in terms of the original components. Is it really necessary? Let me think about that. Probably not. So let's just say V If I then take a look at these pictures, V23 is the voltage between these two conductors, but that's this conductor, the one connected to the right-hand side of R1 and the one connected to the low side of the seat of EMF. So it is, by inspection, the voltage across R2 and the voltage across R3. So let's write that down. V2 is equal to V23, and that's what we wanted, was the voltage across R2. So it follows that V2 is equal to IR23, and that's what we wanted. So for any value of the three quantities that I got, I can calculate I can calculate R23, and therefore I can calculate V23. I think I'm going to complete this project by means of two functions. One function calling another function. The one function meets the requirement, and the other function I need to write for the first function to work. So write a function to calculate V2. No, that's not necessary. I'll do it all in one function. So 1 given, what are we given? V comma R1 comma R2. I'm going to go code outline. R3 equals linspace 0 comma 10 times R2. And I think I'm supposed to say how many of them I use. Comma, I go 101. So it's actually going to go in steps of 1/10 R2. And it'll have 101 steps, 100 of them, and plus the one for R3 is equal to 0. So R3 is going to be equal to 0 up to 10 times R2 in 101 steps. I might have to, I'm not sure I remember the exact syntax for linspace, so I'll just doctor that up a little bit if I have to, but I've conveyed the idea here in my code outline. So then calculate, try to see what order I did things in up here. So it was calculate R23, calculate equals 1 over R2. Now that's actually going to create an array of 101 values for R23, and I do have to remember I'm probably going to need to use a dot slash there and maybe a dot slash there in the code, but that's more technical details in the code outline. I'm just trying to get the ideas across. And then calculate, so again that gives me 101 values of R23. 4, let's see, I'm going to go RT, which is equal to R1 plus R23. This will just add the value of R1 to each of the 101 values in there, item by item, and create a set of 101 values stored in array RT. And then calc I is equal to script E. Actually, it was called V here, so I should fix that up. Sorry about that. This is a V, a V, and a V. So V, V, and V. And are there any other places? I didn't label it here. I think that's the only places I see script E, except for my latest one, which got me thinking about it. So I is equal to V over RT, and then I'm going to use this formula 6V2. Again, I'm really going to need the dot slash there. V is a number, but I'm dividing by 101 values, and that'll give me 101 values of I. And then V2 is equal to R23. And plot V2 versus R3. So graph of the voltage across R2 is a function of value R3 for values of R3 from 0 to 10 times the value of R2. Alright, I think that does it for the pencil and paper part of this problem.